Hello guys, welcome back to Maths African Motives. Still working on our mathematics and six. This is one of the most important part that we're going to talk about, which is going to be important in your syllabus, which is the integration, but working on completing the square. We are using the completing of the square method. Okay. You need to understand your completing of the square from your mathematics N3. So I want you to take time again to go back to that N3 stuff and revise your completing of the square method. We talked about that in our N3. So you're gonna make sure that you work with that completing of the square method video on N3 so that you can just have a recap. But as we are revising, maybe you shall understand me. Let us just talk about completing of the square, just basically, just a recap as we are moving on. Remember, on your completing of the square method, you'll be talking of a quadratic expression. All right, let us just say we've got a quadratic expression, x squared plus 5x plus 6. Always, you are supposed to work with the coefficient of x squared being a 1. Remember that, okay? So for you to complete the square, you have to determine half of the coefficient of x, this one. So you're going to need half the coefficient of x squared, like that, okay? The coefficient, what is affecting x is 5. So you're going to need half of 5 squared, okay? Sorry for that. So that's half of 5 squared like this. So half of 5, simply half of times 5 is 5/2. So that's 5/2 squared. Okay, don't simplify this. Yes, you can simplify, but just leave it like that. Okay, so this is what you do with this square. You are supposed to add and subtract at the same time this square that you got here. So here we're going to have x squared plus 5x. You add it on the x part here on x squared plus 5x. You're going to add the square, which is 5/2 squared. Remember, guys, from your N3, plus you take the 6 as it is. So this is 6. You subtract this time, okay? So this time you're going to subtract. What are we subtracting? That square again that we added. So this does not affect our question. We still have our question because it will cancel. As you can see, we added something, we subtracted it again. So it will cancel. But the purpose of us having this is for us here to have a perfect square. Remember, we are supposed to have what we refer to as a perfect square. We are supposed to obtain a perfect square expression. And this is a perfect square. How do you factorize this? You just take the first term and the last term, you square them in a bracket. So the first term squared is x. The last term squared is 5/2. So you're going to take these, you square them together, the first squared, last squared. Then on the constants, you combine them, this part of the constants here. So there we had a perfect square of a quadratic expression. You factorize it like this. Then the rest, you just combine on your calculator. So you're going to combine what is remaining on your calculator. This here. So let us just save our calculator and simplify this together. That's 6 minus 5/2 squared. 6 minus 5/2 squared. Like this. This is going to give us minus 1/4. All right. So that's negative 1/4. Like this. This is what you're going to have. Negative 1/4. We have completed the square. In this case, this is a perfect square expression. We have factorized it. We have completed the square. But some of us, we might have a challenge of recalling half of this and that. If you're such a person, therefore, I want you to memorize this formula because we are not yet having this formula in our formula sheet. But you see, in most cases, this formula is being used and we can actually use it to complete the square. Which formula am I talking about? All right. It follows that if I am given a quadratic expression, ax squared plus bx plus c, this is equivalent to 4ac minus b squared, everything over 4a, plus a into the bracket of x plus b over 2a squared. Just like that. This is the formula that you just need to memorize. This is from a normal quadratic expression to a completed square. So this is how you can complete the square. So it's a choice. The choice that you make, it's either you're going to use this or you're going back to this one. Okay. Let's talk about this formula here. Ax squared, we are simply taking from the formula, a being the coefficient of x squared, b the coefficient of x, c is the constant. So on this question that we are given, we could have completed the square by x squared plus 5x plus 6, right? So the coefficient of x squared is 1. So we've got a, we've got b, we've got c. So let us substitute this and see what you're going to have. So it means that our x squared, all right, let me just write it this one. Our x squared plus 5x plus 6 is going to be equal to 4ac. So this is 4 times a. Let us just even open bracket. It's fine like that. Open a bracket times a. Our a is 1 times c. Our c is 6. All right, minus b squared. So this is b, which is 5. So it's going to be 5 squared. Everything over 4a. This is 4 times a. A is 1. So this is going to give us a 1. Plus a, which is a is 1. So this is just 1 into x plus b over 2a. Our b is 5. So this is going to be 5 over 2a. That's 2 times a. A is 1. All right. So this bracket is being squared. So this is what you're going to have. So here we can just use our calculator to simplify this at once. Okay. That is going to be 4 times 1 times 6. All right. Okay. Sorry for that. Just going to need one fraction there like this. So that's 4 times 1 times 6 like this. Minus 5 squared. All right. Everything over 4 times 1, which is just 4, guys. All right. 4 times 1. Okay. This is minus 1 over 4. So we're going to get minus 1 over 4. Okay. Plus this is a 1. So 1 does not affect, just leave it like that. So you're going to simplify what is inside of the bracket. So this is x 5 over this. So this is just 5 over 2. All right. So this is just 5 over 2 squared. So as we can see, this here is exactly what we have on this part. Okay. We just have to start with a positive. Just start writing this with a positive. So it's x plus 5 over 2 squared like this, minus 1 over 4, which is the same as this one. So completing of the square method is in your hands. It's in your hands. How are you going to simplify? It's up to you. Are you going back to use this traditional method that we are used to? Or are you going to use the formula? It's up to you. All right. This is not my part of the class. The part of the class is to use integration, to integrate. The method, yes, is the one that you're supposed to know. Like I said, it's your N3 stuff, that one. Okay, so let us go to the topic. How do we integrate now? So let us talk about this. We're going to talk about this with questions. Let us say we are asked to integrate, because we are supposed to integrate by completing the square. So definitely you'll be given quadratic expressions, right? Maybe under the square root or whatever the type, but there will be a quadratic expression like this one, the integral of 6x. So this is the integral of 6x minus x squared with respect to x. So this is what we have. So what you do is that you take the quadratic expression under the square root or whatever that you have, the way that it is written, you complete the square. So we are going to complete the square on the quadratic expression. So we are going to complete the square. All right, so you're given a quadratic expression here, which is 6x minus x squared. Remember, this can be written as minus x squared plus 6x like this. So from the traditional method, which is the original way of weighing this, we can factor out a negative because we want always x squared to be a positive. So you don't divide. This is not an equation, all right? It's an expression. You factor out the negative. So you're going to factor out the negative. This becomes a positive. So it's x squared. 6x divided by negative, that will be negative 6x. We do not have the constant. So this is what we want to complete. We want to complete this to be a perfect square. So like I said, in order for you to complete this, you're going to need half the coefficient of x squared. So we are going to need half the coefficient of x squared, the coefficient of x, which is minus 6, but we square this. So what is half of minus 6? Half of minus 6 is minus 3. So this is minus 3 squared. Yes, we know that minus 3 squared is 9. But like I said, don't simplify. Don't simplify. Just leave it like that so that you properly see exactly what you're going to use in the bracket. So this is going to be minus. We open the bracket here. So this will be x squared minus 6x. What did I say about this square? We have to add the square to this algebraic. And at the same time, we have to subtract that. So we are going to add the square, which is minus 3 squared. Since we do not have a constant like the previous case, we do not have a number here. So we're just going to subtract as it is. Subtract the square that we added, which is minus 3 squared. So we added it. We have to subtract it so that we neutralize our question. Our question is just as it was before. It hasn't changed. But the purpose is that we can do our factorization in an easier way because we are going to factorize this quadratic part that is our perfect square, this one. So how do we factorize this? I said you take the first squared and the last squared in a bracket, all right? So this will be minus. We're going to have something like this. The first, which is x, the last, which is minus 3, all being squared, all right? Then you simplify the rest. So this is the rest on our calculator. It's minus 3 squared. So that will be minus like this, minus 3 squared like this, which is a negative 9. So there we are going to get a negative 9. All right, so that's a negative 9 like this. All right, so the negative that is outside of the bracket, it has to affect what is inside of the bigger bracket. So it's going to affect this part. We distribute by negative here, we distribute by negative here. All right, so if we do so, it's going to be negative times this, which will be negative into the bracket of x minus 3 squared. It cannot be written inside of the bracket. We just write outside of the bracket, okay? The negative, it multiplies negative 9, so it will be a positive 9, negative, negative. So this will be a positive 9. We are done. So this is what we have, which can be written as, starting with a positive, this is 9 minus x minus 3 squared like this. So we have completed the square. In this case, we have completed the square. So like I said, this is not the only way that we can do this on completing of the square method. We can use the formula, all right? We can complete this by using the formula. We saw that from the formula of ax squared plus bx plus c, we can use this we can use this to be written as this expression, which is being completed by completing of the square method. So we are going to have this as 4ac minus b squared, everything over 4a. All right, plus a into the bracket of x plus b over 2a squared. So that's it. So let us have our letters A, B, C, and so forth. So this is what we have, minus x squared plus 6x. This was our original expression from 6x minus x squared. So it means our A in this case is a 1. It's minus 1. This is the coefficient of x squared. The coefficient of x, which is b, is going to be a 6. C is a 0. We do not have that, so it's a 0 like that. So we have got A, B, C. C is a 0, it's not there. All right, so this is what you're going to do. You're going to substitute here. So it's 4ac, guys. C is a 0, so anything that we multiply there is going to be a 0. So it's at 0 minus. b squared, whereby b is 6. So this will be 6 squared over 4a. That's 4 times a. Our a in this case, which is -1. So a is -1 plus a in this case, it's -1. So that's -1 into the bracket of x plus b over 2a. b is 6. So that's 6, which is our b. So it's 6 over 2 times a, which is 2 times -1 squared. All right, so we simplified this on our calculator to complete the square. That will be 0 minus 6 squared. All right, let's just put a fraction first. 0 minus 6 squared. Minus 6 squared like this over 4 times -1. 4 times -1, which is 9. So that is going to give us 9. Plus and minus gives us a minus. So it's going to be minus, open the bracket, x. So it's 6 over 2 times -1. 6 over 2 times, that's 6 over -2, which is -3. Or we can just use our calculator again. 6 over 2 times -1, 2 times -1, which is -3. And everything is being what? Is being squared. All right, so this is from the formula. So as you can see, if you know the formula, it's like direct. I don't know. You choose what is best. As for me, anything is best for me. Okay, it's either this or this. Okay, so you choose what is best for you guys in order for your simplification to be done. So we have completed the square. So the method is in your hands. It's your choice on how to complete the square, but the answers should be the same. So with these answers that we got, what we were doing here is to complete the square of this part. But take note, we are supposed to integrate. What are we supposed to integrate? We are now supposed to take back what we completed. So this is supposed to be the integral of the square root of the answer that we got. So this is the square root of the answer here that we got after completing the square. We got 9 minus x minus 3 squared. All right, so this is what we got. Just gonna write as it is. So that is 9 minus x minus 3 squared, like this, with respect to x. So take note, it's under the square root. So this was our question, all right? We took the quadratic, we completed the square with any of the methods that we want to apply. We completed the square. Now we are supposed to integrate this. So the question is, how are we going to integrate this part? Okay, this is what you do. You go to the formula sheet. I want to teach you something that is very, very easy so that you can be able to answer any question of this nature. You go to your formula sheet. Under formula sheet, there is this part of, it's only that I removed the page numbers here. But if you check, there's this page where we are given these integrals. So we go to these integrals starting from this one, starting from this number 1, number 2, number 3, number 4, number 5. I think that's number 6. Yeah, there's another one here. So these are the ones that always you are going to look into, these integrals. You see, these integrals, this one. You are supposed to look into these integrals always. Always, okay? Always, guys, always. Okay, so this is it. From our question, I hope you still remember our question. I'm just going to take, this is where we have some our integrals. I'm just going to write our question here so that we pick the best integral. Yes, I'm going to write it aside, but I want you to see. Remember, we are at this stage. The integral of 9 minus the bracket of x minus 3 squared with respect. This is where we were on that question. So we are supposed to check the one that goes with the format that we have here. The first thing is we have a square root. So it's the square root of. So let's check here. We have a square root, yes, but it's a fraction. It's like 1 over. It's not 1 over this one. So this one, it's out. You move on to this one. We do not have a square root. So this one, it's out. Okay. We move on to this one. The square root of a squared minus b squared x squared. The square root of it, there's no 1 over. So this is exactly what we want here. Okay. If you check the next one, we do not have the square root. So this one is out. Here we have got the square root, but this is the square root of x squared plus or minus. The format here is not what we have. Here we have got a squared. It's a constant. This is what we have, a constant. All right, this is this is plus b, plus here. Here there is a plus. So this one, okay, is an oak here. So guys, sorry for this. This thing of using a soft copies, your eyes, they end up like disturbed. Sorry for that, guys. Okay, this is it. I wanted you to see this one here. So this is exactly what we have here on this formula. If we check properly, we've got a constant, which is this, a constant minus, okay, the b squared. I'm going to explain about that. Okay, so this one is not going to work because x squared is positive. This one is not positive unless if we're to factor out, but it's going to be a challenge because you can't find the square root of a negative. So this one is out. And also this one is out because it's 1 over. We do not have 1 over. So this one is out. So this was going to be the best formula to use. This one. This was going to be the best formula to use. Okay, so I'm going to rewrite this formula and explain why am I saying it is the best formula to use. Okay, remember we saw that from the formula, we are supposed to integrate this. And we saw from that formula that it was written as the integral of, so this is something that we're just going to use. I'm not going to have as part of our question. It was the integral of a squared, like this, a squared minus b squared x squared with respect to x is equal to a squared over 2b, and this is arcsine of bx over a, okay, plus x over 2, the square root of a squared minus b squared x squared plus c, okay. So if we check here, this is what you're supposed to integrate this one. You're supposed to integrate something of this format. And a squared, that is, if we check, 9 can be written as a squared. So it's going to be 3 squared. So this here is going to be written as the integral of, we are not changing anything. We're just rewriting in a format that is written a squared. So 9 is same as 3 squared. We haven't changed anything. Minus b squared is a constant, so we do not have a number here. Remember, 1 can be written to the exponent of any number, so this can be written as 1 squared. So b, it simply means there is a 1. So it simply means there is a 1 squared, representing what? Representing b. Then x squared is the part that we have of x, this one, which is what? Which is x minus 3 squared. So that is exactly the format that we are given there. So this one is the one that represents our a squared. So there we have got our a3 represents our a, 1, our b, x minus 3, our x. So this is our a, this is our b, this is our x. Because we're supposed to have a squared, b squared, x squared. So a is 3, b is 1, x it's x minus 3. X is represented by x minus 3, the whole bracket of x minus 3. So you just substitute into the formula. That's how you answer this question, all right? You substitute direct as it is. So this is a squared. A, remember, is what? 3. And 3 squared is what? It's 9. So this will be 9 over 2b. So it's 2 times b, which is 2 times b. Remember, b is what? It's 1. Remember, we said b is 1, like 1 squared. So b represents what? 1. So 2 times 1 is, it's a 2. So this is just going to remain as 9 over 2. Arcsine, so this is going to be arcsine of bx. B, remember, it's 1. So 1 times any number, guys, it remains as it is. So it's just going to be 1 times x, bx, x, x, x. Take note. And we said x is represented by x minus 3. So it's going to be x minus 3 like this. So it was supposed to be like this. It was supposed to be bx. It was supposed to be 1 times x minus 3. But 1 times anything remains as it is. So it's just x minus 3 over a. So this is everything over a, like this. So our a in this case is what? Is 3. So this is 3. All right. So let me just put the bracket at the end like this. X minus 3 like this. X minus 3, everything over a. And we said a is 3. All right, let me just put it this way as a single term. So this is how we work out this one, plus x over 2. We're just substituting x over 2. Our x is represented by what? By x minus 3. That's your x. So that will be x minus 3 over 2. All right, the square root of, so this is going to be the square root of a squared minus b squared x squared. If you check properly, this is what you have here exactly. Sorry, this is what we have here. A squared minus b squared x squared, which is exactly what we had on our question here. So instead of you rewriting 3 squared minus 1 squared, 3 squared, we know it's 9. So we are not going to rewrite, we're just going to take as it was from the original question. So that's 9 minus x minus 3 squared. So that is what you have, plus what? Plus the constant of integration. So on this side, we're going to have the constant of integration. All right. So that is it. We are done. So this is the whole solution you are supposed to have in your integral. If you are to integrate this, the answer is supposed to be like this. So like I said, you just take it direct from your formula sheet. So completing of the square method, this is how you end up with. So the first part, you complete your square with whatever method, whatever way that you want. But after completing the square, after you have completed the square now, here on how to integrate this part, whether it's under the square root or what, always after completing the square, go back to these formulas, all right? Think of these formulas first whenever you're dealing with what? Completing of the square. One of these formulas is supposed to match exactly the format that you are given. Do not force something to be used where it is not applied. It must be of the same format. That's why I had to check each of these. Which one corresponds to what we are given? It must be in this exact format. If it is in the exact format as this, therefore, you can use that formula. You integrate, you just write the answer by substituting there. That is how you can integrate this. If you can memorize those ones, it's up to you, but you'll be a big machine. There's no need for you to memorize that just because you have the formula sheet, guys. So what you just need is that you just need to, okay, after completing the square, I have to go back to those formulas. That's it. The formula is going to do everything, okay? I want you to see this one. All right, let's have the question 2. Integrate 1 over the square root of, so this is 1 over the square root of 1 plus 3x. So this is 1 plus 3x minus x squared with respect to x. So this is what you're given. So like I said, always the first thing is to complete the square. So we are supposed to complete the square of the quadratic expression that we see. We've got a quadratic expression of 1 plus 3x minus x squared, which can be written as starting, remember the format. So you're going to start with x squared minus x squared plus 3x plus 1. So using the traditional method, we said the coefficient of x squared always is supposed to be a positive 1. So you factor out negative 1. If I factor out negative 1, this will be minus, divided by minus, it becomes a positive. Positive divided by minus, it's a minus. Positive divided by minus, it's a minus. So that's it. Then we said after that, the coefficient of x squared is a positive 1. Always it's a positive 1. You determine half the coefficient of x, and this is the coefficient of x. So you're going to need half the coefficient of x squared. And that is half of minus 3, which is minus 3 over 2. So that's minus 3 over 2 squared, like this. Okay. So the square is supposed to be added and also to be subtracted on this. So this is going to be minus into x squared minus 3x as it is. You add the square. So you're going to add this square, which is minus 3 over 2 squared. Okay. You write the constant that was there, minus 1. We subtract the square that we added before. So you're going to subtract minus 3 over 2 squared, like this. All right, so let us just put these brackets like this. Let's just do it this way. All right, we close this bracket. Okay, that's it. So here we're going to have minus. Now we factorize. So that will be something of this nature here. So like I said, on this part of your perfect square, the one that you have now completed to be a perfect square, you take the first squared and the last squared. The first, which is x, the last, which is -3/2. You square those terms together. All right, that's how you factorize, just like that, guys, okay? Then the rest you simplify on your calculator. Let's see what you're gonna have on this one. So this is -1 on this part. So that's -1 minus, okay, gonna have a fraction. Minus, all right, the bracket first. Let us just have bracket first. -3/2 squared. So that's -3/2 like this squared. So you're gonna square this. That will be -13/4. All right, so this gives us -13/4. So this is exactly what we are having. Okay, -13/4. So with the negative that is outside of the bracket, we expand everything by this negative. So it's negative times this, which is negative bracket x -3 squared minus and minus here is going to be a positive. So that will be positive 13/14. So like I said, you can even start by writing a positive value. So this will be 13/4 minus, we've got x -3/2 squared, like this. So we have completed square. Using the traditional method, that's it. Okay, but I said we can also use the formula. Using the formula, we said, okay, I'm just gonna rewrite, it's good for recap again. Ax squared plus bx plus c can be written as 4ac minus b squared over 4a plus a into the bracket of x plus b over 2a squared. Okay, I had the way that I'm writing, you're supposed to do it like that. All right, anyways, this is it. We, after rearranging this 1 plus 3x minus what, we saw that this is going to be our expression minus x squared plus 3x plus 1. We've got minus x squared plus 3x plus 1. All right, minus x squared plus 3x plus 1. Is it a plus 1? It's a minus 1. It's a plus 1. Minus x squared plus 3x. Okay, so this is what we have. So that is, we're going to have -1, +3, +1. So we've got the coefficient of x squared, which is a, b, and c. So let us just substitute direct into the formula. 4 times a times c, that is 4ac here minus b squared. So it's 4 times a, which is -1 times c, which is 1 minus b squared, our b, which is 3. So this is 3 squared. Everything over 4 times a, which is -1, plus a, which is -1. So that's -1 into the bracket of x plus b over 2a. Our b is 3/2 times a, which is -1 in this case squared. So here we can simplify on our calculator as usual. All right, as usual, guys. So let's bring this to consideration. That's 4 times -1 times a +1. Then we're going to subtract 3 squared. Everything over 4 times -1, that's 4 times -1. On your calculator, everything can be done like this. We get 13/4. So this is 13/4. Then the other side is just gonna simplify here. Plus and minus, that's a minus. So it will be minus the bracket of x. Then this is 3/2 times minus 2 times -1, that's a -2. So it's 3/-2, which is same as -3/2. Plus and minus gives us a minus, remember that. So that's it. We have completed the square using the formula, getting the same answer that we obtained here by the traditional method. All right, so these are the two answers that you can see that they're just the same. So I don't care which method that you are going to use, it's up to you. What I care is, are you going to apply your integral later on properly? That's my major concern. This one, guys, we talked about this, N3, this is N3 stuff, completing of the square. This is your N3 stuff. My worry now is here. After that, you have completed your square. You are going to take back into consideration. So this is going to give us the integral of 1 over the square root of, remember we completed the square, we got 1 over the square root, we got 13 over 4 under the square root minus x minus 3 over 2. This is what we got, minus 3 over 2 squared. With respect to x, we're just taking this as it is, what we got here, 13 over 4 minus as it is. So like I said, my worry is here. How are you going to integrate this? How are you going to integrate that? So that's why I say you go back here. Okay. There is one formula applicable there. Only one. Okay. Let's remove this. There's only one formula. Remember? Okay. Let me rewrite so that you can properly see it. It was the integral of 1 over the square root of 13 over 4 minus x minus 3 over 2 squared. Remember, this is what we had. So there's supposed to be 1 over the square root of something. All right, this is what we see here. Let's check the first one. dx means this one is same as 1 over. The dx is same as it's written here. Remember, this one, 1 times dx is same as this dx here. If I write dx, I don't write it. It's one and the same thing. All right. So if we check, it is the same thing that we have here. This is the square root of a squared minus b squared x squared. So this can be written as a squared. Here we can write this as a squared. We can write this as b squared. We can write this already squared. All right. So that is what we have here. So this is exactly what we have here. This one here. So we're going to take this as it is. Okay. So I'm just going to rewrite that. Just going to rewrite. All right. No problem. Let us rewrite this, guys. I just want you to see this. That's why I'm doing this. I want you to properly see this. All right. So let me rewrite here. Remember, we saw that the integral of dx, it was given with dx on top. dx over the square root of a squared minus b squared x squared is equal to 1 over b arcsine of bx over a plus c. So you see, you guys take your time. Go back and take your time here. Go back and take your time. You will see that there is no other formula that is applicable that we can use there. Of all these formulas, there is only one, only one. So take your time, do not rush. Make sure that you choose a proper formula. There will be always one. Okay, so this is it. We saw that this is the most relevant or the most appropriate formula. It's closer to what we have. Even though here we do not see the a squared, but there is we can write this, the 13 over 4 can be written as a number to the exponent of 2 because we need a constant squared. So how do you do that? You just find the square root of 13 over 4. So this is it on your calculator because we know that the square root of a number squared, it gives us this. So you determine the square root of that number, the square root of 13 over 4 like this. It gives us the square root of 13 over 2. So it means instead of me writing 13 over 4 like this, I can rewrite it in the format that is given here that I understand. So this is the same as the integral of 1 over, we saw that this can be written as, so that's the square root of 13 over 2. We saw that from our calculator. That was the square root of 13 over 2 like this. So it is going to be squared so that if you square it, it goes back, it gives you this one. So I want you to see, guys, if you square the square root of what you have done before, it gives you exactly what you had before. If we square, this is square root of 13 over 2. Let's square it. We square the answer like this. It gives us what? 13 over 14. 13 over 4, which is this one. So we haven't changed anything. We are just rewriting in a format that is given here. Otherwise, we haven't changed anything. All right, minus b squared. Are we having a b here? So like I said, b, like 1 can be written as a number. So b squared is same as we've got 1 squared into the bracket of x minus 3 over 2 squared with respect to x. So to write dx here, like I said, dx times 1, it gives us dx. So instead, I can just write my dx here. So it's going to be dx over this. It's just one and the same thing. All right. So this is what you can see. This is your a from a squared, right? This is your a. From b squared, this is your b. From x squared, this is your x. The whole of this part, it represents your x. So it means this integral is going to give us what? Let's check our answer. 1 over b. So it's going to be 1 over 1. Our b is what? Our b is 1. So it's 1 over 1. Arcsine of bx. So this is arcsine bx. So remember, b is 1. So it's going to be 1 times x. Our x is what? It's x minus 3 over 2. This is the part representing our x. Okay? Everything over a. A is represented by what? A is represented by the square root of 13 over 2. Because we've got a squared, a squared, a squared. A is square root of 13 over 2. All right, so take note about this one. All right, so this one, guys, does not even affect anything. All right, plus the constant of integration. So here you can simplify 1 over 1 is 1, so you can just leave it like that. So that will be arcsine of what? Let's simplify this 1 divided to the square root of 13 over 2. All right, let's divide that and see what you're going to have. Oh, it's just the inverse. It's going to be 2 over that. But if you don't understand, then use your calculator. 1 divided by this. Okay, let's see. 1 over, so this is 1 over the square root of 13 over 2. The square root of 13 over 2 like this. So this will give us 2 square root of 13. So here they have simplified this, but in actual sense, it was supposed to be just square root of 13, 2 square root of 13, like that, okay? But here it's they have simplified this, so you can just write as it is, it's fine. So this will be 2 square root of 13 over 13. So that's 2 square root of 13 over 13. All right, so like I said, in actual sense, it was just supposed to be like this, or it was supposed to be 2 over square root of 13. So you can write it like that, which is fine. Or you can write it like this, which is also fine. Okay, so but we still have, because we simplify, this is what we're simplifying, 1 divided to this. This is what we just simplified, but there's still x minus 3 over 2. So you're going to have the bracket of x minus 3 over 2 like that. All right, plus the constant of integration. There's nothing that we're going to do on this one. We're just going to leave it like that. So that is the simplified part of the integral. So like I said, your completing of the square method, guys, it's something else. You need to know what to do after. After that, what is it that you're supposed to do? After you've completed the square, it's not about just completing the square. Which formula are you supposed to use now in your integrals? This completing of the square, you just memorize this formula direct. All right, use your formula, you're done. But after, now, okay, let's see this one, number 3. The integral of 1 over, you'll be given something, and sometimes they give you something that you might even not like recognize that, okay, here I'm supposed to actually complete the square, like this one. Integrate 1 over x plus 1 into x plus 4 with respect to x. Then you'll be wondering, it's a fraction. Yes, it's a fraction. But what is it that you see? The 2 brackets here, they mean something to us. We know that from our factorization. If you expand the 2 brackets, they give you a quadratic expression, ax squared plus bx plus c. This is what we get whenever you expand. And what? When you expand 2 brackets. If they are 3, we get a cubic, ax cubed plus bx squared plus cx plus d. This is what we know. When there are 3 brackets, if they are 2, we get this part of the quadratic expression. So meaning to say, we have that quadratic expression again, but it's just hidden. They just hide in terms of factorizing. So we do the opposite of what they did. They factorized x plus 1 into x plus 3. It was already they factorized something to give us these brackets. So as we're going to expand so that we see what was that expression before. X times x, that will be x squared x times 4, that will be 4x. We're done with x. We move on to 1. 1 times x, which is going to be x. 1 times 4, which will be plus 4. So if you combine this, this will be x squared. 4x plus 1x, this will be 5x. This is same as we've got 1x. So it's 5x plus a 4. So this is what we are having. But they just hide it for us. This question was supposed to be given integrate 1 over x squared plus 5x plus 4 with respect. This is how the question was supposed to be given. Like, but you see, they want to hide this for us so that you don't see it. So you have to open the other eye in exam so that you see how to attempt the question. All right, anyways, at this stage, you complete your square just like the previous case, all right? If I want to use the traditional method, already the coefficient of x squared is 1, so it's an advantage on that part. So I'm just going to find half the coefficient of x, I square it. So half the coefficient of x, which is half of 5, I square this. So half of 5 is 5 over 2. So that's 5 over 2 squared. Remember, we have to add and subtract the square. So you're going to have x squared plus 5x. We added the square first, 5 over 2 squared. All right, the constant. Then we subtracted that square that we added before, which is 5 over 2 squared. All right, then do factorize your quadratic expression, which is a perfect square in this case, this one that we have. And like I said, to factorize this, you take the first and the last squared. So the first, it's x. The last, it's 5 over 2. You square everything. All right, then the rest, you have to simplify that, okay? Combine everything on your calculator. So that will be 4 minus 5 over 2 squared. Just open a bracket, 5 over 2 squared, like this. So this will give us negative 9 over 4. So we are getting negative 9 over 4 like that. All right, and of which we are done. There's nothing that you're going to do further. That is it. Okay, from our formula of ax squared, this and that, we saw that the formula is going to end up with 4ac minus b squared over 4a plus a into x plus b over 2a squared. If you use the formula, that will be, we can take it from this side, or definitely you're going to expand. And at this stage, that is where you use the formula. So this is your A, your B, and your C. Okay, that if you want to use the formula, so that will be 4 times A, which is 1 times 3, which is 4 minus B squared, which is 5 squared over 4 times A, which is 1, minus, plus A, which is 1. So that's 1 times X plus B over 2 times A, which is 1. All right, our B is 5 here. Sorry, this B is 5. So that's 2 times 1 squared. So when you simplify properly, guys, this is going to give you negative 9 over 4. All right, so make sure that you simplify properly on your calculator. Then this is plus 1, x 5 over 2 times 1, which is 5 over 2. So that's 5 over 2 squared, which is this part is going to start with a positive, all right? So you have completed the square with any method of your choice. So let's have our answers here. So this is what we're going to have. This is what we're going to have here. All right. This whole part is going to give us the integral of 1 over, remember, we completed the square and we got x plus 5 over 2 squared minus 9 over 4. So this is x plus 5 over 2 squared, x plus 5 over 2 squared minus 9 over 4 with respect to x. We are integrating, remember. So this is it. This is it. At this stage, like I said before, that's where my worry is. So at this stage now, we have to go back to our formulas. Which one is the best? There's always one formula there that is best suitable to our question. Remember, our question now is to integrate. We are at a stage where we are supposed to integrate 1 over, it was given as what? X plus 5 over 2 squared minus 9 over 4. This is the stage that we are. So we need this format. There's no square root, there's no one. So the first one is not going to work because there is a square root there. So the first one is totally out. Okay, let's move on to the second one. The second one is out. Again, we do not have a square root. This one is out. Oh, sorry, the second one, it's out because of the format. All right, it's a squared plus. You can be used when you are adding. Here it's out because we've got a square root. All right, this one, dx over a squared minus b squared x squared. All right, so this can be of something. It can. Okay, let's leave it for the meantime. Let's leave it, but it can work. I want us to see the other one. This one is totally out. We've got a square root. This one, there's a square root. So this is the only formula that we can have that is applicable, because here you see what I'm saying? Here there's a positive, because if you see it's familiar or it's similar to this. So you wonder, why am I leaving this one? I'm leaving this because there's a positive. Guys, no matter how you perform a miracle, there is no way you can factor out anything that is positive, like a squared plus b squared x squared, so that one of the terms become a negative, one a positive. There's no way. You can't perform that miracle. If you factor out a negative, both will be negative like this, you see. So we can't have one being positive, one being, it's impossible. But on this one, because one is positive, on this one here, one is positive, the other one is negative. It's best because we know that we can factor out, we can write it in this form, we can change this to this format. So this is the one that is best applicable. I'm going to explain. Let me write the formula first so that I explain it properly. Let me write it way on our worksheet here. So this is what we have. We said that formula at least is the best formula to use. It states that the integral of, it's given like this. They wrote dx on top, which is the same. I told you guys 1 times dx is the same as dx, all right? So it's dx over a squared minus b squared x squared. This is how the formula is given. And they are saying this is supposed to give us 1 over 2ab ln a plus bx into over a minus bx like this, plus the constant of integration. That's what we are told there. Okay, I want you to see this. If you are to consider this, we are not having the format because here we are starting with x, a variable. Here we are starting with a constant. So what you do is that you just start with a constant, but it must be a positive constant. So we can factor out the negative out of the integral, and that will be a negative like this. If you factor out this negative, it means we are left with 1 over, this will be a positive. So it's going to be positive 9 over 4. We're also starting with a constant, all right? Plus x plus 5 over 2 like this. Sorry, if we factor out a negative, this will be a negative, sorry. Because remember, we factored out a negative here. We factored out this negative out of the integral. If we factor it out, it also affects here. So plus and a minus, it gives us a minus. So it will be minus x plus 5 over 2. So that will be x plus 5 over 2 squared with respect to x. And I said this here can be written like dx on top. So if you just want to write this format, yes, you can do it like that. You can just write minus, don't forget the minus. So it's minus the integral, just write your dx on top. It's up to you, this one. But if you understand even like this, just integrate, all right? So this is dx over 9 over 4. We want to write it as a number squared. A, it's a constant, so it's a squared. So like I said, you just determine the square root, all right? The square root of 9 over 4 is 3 over 2. But anyways, we've got the calculator, so you can just determine the square root of 9 over 4 like this. So this is 3 over 2. So it means in place of 9 over 4, I can write it as 3 over 2 squared, because I know that this goes back to the original term. 3 over 2 squares, it goes back here to 9 over 4, because it is the square root of 9 over 4. So the opposite of this, if we square this 3 over 2, our answer it must give us 9/4. So we haven't changed anything. We are just rewriting in a way that we understand. Okay, then minus b. Do we have b? We do not have. So the b is just a 1, so it's just going to be 1 squared. All right, into x plus 5/2 squared, which represents what? X plus 5/2 represents the part of x squared. So that means here, this is our a from a squared, this is our b from b squared, and this is our x from what? From x squared. So this is our x. So this, if you can understand this, you can answer any question. So we saw that this, once we have got this format, it can be answered this way. This is the formula, 1/2ab. So it's going to be 2 times a. Remember, our a is 3/2. So that's 3/2 times b, of which our b is 1. All right. Then we have got the ln of, remember, guys, b is 1 squared. So it's just 1. So the ln of a plus b, remember, our a is 3/2. So that will be 3/2 plus bx. Remember, our b is 1. So that's 1 into x. Whatever x represents is the bracket as it is, which is the bracket of what? X plus 5. That's the part that represents x. So it's x plus 5/2 like this. All right. Everything over a minus. So here we're just subtracting as it is, guys. 3/2 minus 1 into x plus 5/2x plus 5/2 like this. We're just rewriting as it is. All right, so this is it plus the constant of integration. So we can just simplify here. That's okay. Let's see on our calculator, what are we going to have at the end? That's 1 over, so it's 1/2 times 3/2 times 1. 1 does not affect, guys. So this is just 1/3. So this is going to give us 1/3. And also you can be able to expand if you want here. You can leave it like that. So this will be the ln of, you can leave it like this as it is, or you're going to expand. I'm just going to show you. Or you can just leave it as it is, 3/2 plus the bracket of x plus 5/2, because you're affecting by 1 does not affect anything. All right, this is 3/2 minus the bracket of x plus 5/2. Also, this does not affect anything. All right, plus the constant of integration. But you can simplify if you want. You can expand this by 1, right? By 1, then you collect the like terms. Okay, then after that, you have to collect the like terms at that condition. So this is, and also, guys, don't forget we have got a negative here out of the integral. There is a negative there. Out of the integral, we've got a negative. So this whole thing here, is supposed to be affected by a negative. So that's a negative 1/3 here, negative there. So you've got negative 1/3 ln of this. So you can leave it like that. Or like I said, you can even simplify further if you want. Here, let me just put it in another color, because here we are done. We just want to simplify further if you want. So this will be given as minus 1/3 ln of. So if I simplify, this will be 3/2 multiply here by 1. So it's 1 times x, which is x. 1 times 5/2, which is 5/2. You add this on your calculator, this will give you a 4. So that's 4 plus x. All right. Over, you do the same thing, you expand the bracket here. So it will be 3/2 minus times x, which is minus x, minus times 5/2, which is minus 5/2. You subtract 3/2 minus 5/2, you get a -1. So it's going to be -1 minus x. Remember, there's a minus x there, plus the constant of integration. So you can have your answer that way if you want. Or you can just leave your answer at this stage. So it is of very, very importance that you understand your completing of the square method. Use the using of the formula proper as illustrated in the formula sheet. Simplify as far as possible. That is what you need. Use the formula properly as given in the formula sheet. You have to substitute properly on that formula. Then you simplify as far as possible. The rest of your integrals lies on the formula sheet. The first part, you have to be very, very careful on your completing of the square method. You have to understand how to complete the square. That is how you're supposed to work with it. You're supposed to understand it, how to complete the square. But after everything is done, after you are done with your completing of the square, you then apply back now your method. All right. So like I said, there are so many questions. We cannot like answer all of them. We're gonna have question papers that will come again together, work with them. But let us just see this one. This is November 2018, where we are given the integral of 1 over the square root of 10x like this minus x plus 2 squared. X plus 2 squared with respect to x. This is what you're asked to integrate. So if you check, we've got a quadratic there. It's just hidden there. So you have to play around and see, open your eyes and see that, okay, this is actually a quadratic here. They just want to give us something to confuse us, but it's exactly what we understand here. This is 10x minus the bracket of x plus 2 squared. All right, remember your theorems from your mathematics N3, how to expand x squared. This will be minus, this will be x squared. You multiply this by 2. First and last, you multiply them by 2. So it's going to be 4x plus the last squared, which is 2 squared, which is a 4. All right. Or just expand 2 brackets, x plus 2, x plus 2. There you expand your bracket. This is what you're going to get. All right. Then after that, we can just expand by negative before you complete the square. So that will be 10x squared. Here we multiply. Where am I getting x squared? This is 10x. Where am I getting 10x squared? All right, this is 10x. So that will be 10x minus x squared minus 4x minus 4. Expand everything, then collect like terms. So if we're going to minus x squared, 10x minus 4x, that will be 6x. So this is positive 6x. We are left with negative 4. All right, then we can complete the square on this one using any of the methods that we talked about before. It's either you're going to use the formula or so forth. I don't know what is best for you guys, but I'm just going to use the traditional method. Then I want to challenge you to use the formula. Use the formula, please, so that we see if we are getting the same answer. So from the traditional method, I'm going to factor out the negative. All right, so complete the square. Complete this square. So we're going to factor out the negative so that this becomes a positive. So that will be positive x squared. 6 and negative, it will be negative 6x. Negative 4 and negative, it will be a positive 4 like this. Then, like I said, you determine half the coefficient of x. Half of negative 6 squared. Half of negative 6, that's minus 3 squared. So you're going to add and subtract that square. So it's going to be x squared minus 6x. We add the square, minus 3 squared plus 4. We subtract the square. All right, so that's it. Then we're going to factorize the quadratic. Take the first squared, the last squared together. So that is going to be the first, which is x, the last, which is minus 3 squared. All right, then the rest here, you simplify on your calculator, you were going to get a negative 5. All right, then you're going to expand by negative. So that will be negative into this bracket. So it's negative bracket x minus 3 squared, negative and negative, it'll be a positive. So that's positive 5. So like I said, you can even start writing a positive number, which is 5. So it's 5 minus the bracket of x minus 3 squared, like this. All right. So this is what we have. Let us just leave it like that. We do not know what is the appropriate formula. So like I said, please do challenge yourself by completing the square using the formula. All right, so that you see if you properly understand this part. All right, so let us take this together and see which is going to be the appropriate formula. All right, so remember that was our question here, and we did everything, got 5 minus this. We're going to integrate. So this is what you're supposed to integrate here. We are supposed to integrate 1 over the square root of what we got here, 5 minus x minus 3 squared, all right? So this is 5 minus bracket x minus 3 squared with respect to x. All right, so I don't think this is necessary for now. Let us just remove it. Okay, so this is what we have, and we are supposed to integrate this. So let us check for the best formula. So like I said, always think of the best formula from your formula sheet. We are now at a stage whereby we are supposed to integrate 1 over the square root of 1 over the square root of 5 minus x minus 3 squared with respect to x. So what is the best formula here? The first one gives us the best. All right, this is actually the best because we've got dx over the square root of a squared minus, and this is the format that we have. The second one is totally out, this one totally out, this one is totally out, everything. All right, so if you have got, but everything is totally out, this is the best formula that you're gonna pick. So I'm just gonna take this one. Let us see into consideration. So from the formula, it states that the integral with respect to x of the square root of, it was given like this, a squared minus b squared x squared, like this. This is what we are given. It is going to give us 1 over b, so that is 1 over b x sine bx over a, x sine bx over a plus c. Okay, so this is what we have here. Remember, 5 can be written as a squared, which is 5 square root of 5 squared. So this is simply the integral of 1 times dx is the same as dx. This is the same as there's dx on top. So this is it. The square, or we've got the bigger square root, the major square root, this one. Then the 5, we want to write this 5 as a number to the exponent of 2. So that's, we're going to have square root of 5 squared. So that will be a square root of 5 squared, like this, all right? Minus, already this is squared, but we do not have b, so b squared is just going to be 1 squared. If the number is not there, you write it as 1, all right? So that's it. So let's integrate. So this is going to give us what? So we have got our a from a squared, our b from b squared, our x from x squared. So that is going to give us 1 over b. So it's 1 over b, which is b is 1. All right, x sine of bx. b is 1 times x. X is the bracket of x minus 3. Everything over a is the square root of 5. So that's it, plus the constant of integration, 1 over 1 is 1. So it's going to be x sine of 1 times x minus 3 is just x minus 3 over the square root of 5. All right, plus the constant of integration. So you can even leave it like this at this stage. Okay, so as we can see, the simplification, the integration, the integrals are in your hands. They are in your hands. I'm not going to talk much. I want you to revise as much questions as you can. I want you to do as much questions as you can. It's a repetition throughout and throughout. All right, it's a repetition throughout. Even if you check this is November 2023. I'm seeing this one here. I'm having a question paper for November 2023 here. All right, this is November 2023, where we were given integrate with respect to x. It was 1 over 8 minus 2x. 8 minus 2x minus x squared with respect to x, November 2023. So as you can see, we talked about this. So this is just going to be a completed square, all right? Use your formula and so forth. So since we use the traditional method, this time let us use the formula, guys, all right? You're going to have minus x squared minus 2x, all right, plus 8. So on the formula, it does not even matter about this to be a positive or negative. We just use as it is, all right, because the formula is direct. So remember, our formula states that we're going to have 4ac by completing the square is going to be 4a squared, 4ac minus b squared over 4a plus a into x plus b over 2a squared, like this. So that's going to be equal to 4 times a is -1, so that's -1 times c, which is 8, minus b squared. Our b in this case is -2. So that's -2 squared. Everything over 4 times a, which is 4 times a, which is -1. Plus a, our a is negative, so it's going to be plus -1 into x plus b. So this is b over 2a. Our b is -2, so that's -2 over 2 times a, which is 2 times -1, like this squared. All right. So I want you to simplify these guys direct on your calculator properly. Please do that properly. You are going to get a 9. So this is going to give you a 9. That is what you're going to get in this case. All right. So here we are going to get a 9. Then on this part, you're going to have minus. We simplify this. All right. So here's minus cancels the positive. 2 and 2 cancels. It's going to be a plus. So it's going to be x plus 1 squared. So that's it on this part. That's how you were supposed to play around with this question. All right. So in case of your simplification, be very, very careful. In case of your simplification, be very, very careful how you simplify and so forth. All right. It's very, very important that you do your simplification properly. Let me just confirm this one, guys. I just want to see if I used my calculator properly here. Let me see. 4 times -1 times 8. All right, minus 2 squared. Minus 2 squared over 4 times -1. All right, that's a 9 exactly. Okay, so that is how you just work out this one. Okay, then from there, we can just substitute back. So this whole part here is going to be 1 over this and that. So that is going to be the integral of 1 over. All right, so here, let us just write it on top. So it gave us 9 minus x plus 1. So like I said, this time I'm challenging you to use the traditional method to simplify and see if you're going to get this answer, okay? So let us substitute here. So it's going to be 1 over 9 minus x plus 1 squared with respect to x. And I think we talked about this integral of this type. Yes, we talked about this before. So anyways, no problem. We have to check for the appropriate formula. If there is an appropriate formula that can be used, let us check 1 over, okay, let us just see. Remember our question is the integral of 1 over, it's now 9 minus x plus 1 squared. So we have to check for the appropriate one. 1 over this square root does not work because there's a square root here. Here there's a plus, does not work. Here does not work. Yeah, this one is gonna work. Like I said, we worked with this formula. We used this formula before. Anyways, I'm just gonna rewrite this. I explained this one, so I'm not gonna explain much. Let us just say for formula, guys. I talked about this formula before. We said the integral with respect to x of a squared minus b squared x squared is equal to 1 over 2ab, the ln of a plus bx over a minus bx plus the constant of integration. Remember, I talked about this. So this is it. If you have to check properly, we do not have a square root. This can be written as 1 over, and 1 times dx is dx, so it can be written as dx over 9, which is same as 3 squared. So the square root of 9 is 3, so this is 3 squared minus b squared. We do not have, so it's 1 squared into x plus 1 squared. So that's it. Let's integrate and see what you're going to have from that part. So this is your a from a squared. This is your b from b squared. This is your x from x squared. So that's a, b, and x. A squared minus b squared x squared. So the answer is, say, we are supposed to have 1 over 2ab. All right. So that's 1 over 2 times a. Our a is 3 from 3 squared. Our b is 1. Okay. Then we have got the ln of a plus bx. So our a, remember, is 3. So that's 3 plus bx. Our b, it's 1. So it's 1 times x. X is represented by x plus 1. This whole part represents x plus 1. Over a, which is 3, minus here, we're just subtracting x plus 1 like this. So this is what you have plus the constant of integration. So that's 1 over, if we simplify this, you're going to get 1 over 6. So that's 1 over 6, the ln of. So like I said before, you can leave your answer like this. 3 plus the bracket of x plus 1. 1 here does not affect, so it's just going to bracket of x plus 1 over 3 minus the bracket of x plus 1, like that. You are done at this stage. You can leave it at this stage like that. Okay, but if you want, you can expand your brackets. All right, so here let us just write in another ink so that it does not affect our question. So we can even expand if you want. So this will be 1 over 6. The ln of, if you expand here times 1, it's going to be 3 plus 1 times x, which is x, 1 times 1, which is 1, 3 plus 1, which is 4. So that is going to be 4 plus x over, we do the same thing, we expand by negative 1 here. So it's going to be 3, negative 1 times x, negative x, negative 1 times 1, which is negative 1. Then we can subtract 3 minus 1, which is 2. So that will be 2 minus x. All right, there's a minus there. So it's going to be 2 minus x plus the cost of integration. This one, it's up to you how you want to simplify later on, but you can even leave it at this stage. So you see, after you have completed the square, after you've done with your completing of the square method, how to integrate is the most important, and is the part that you're supposed to take with a pinch of salt. So these are the integrals that you're going to have. I don't know which one is going to be best. Yes, we might not have worked all of these ones, but I just hope as we are revising question papers, we shall use one of the formulas that we did not use in this class. So just be tuned in for more classes from Maths on African Motives till we meet again.